Okay, let's dive right in. We're looking at a really groundbreaking study that uncovers this kind of hidden war happening inside the bodies of children with cancer. While these incredibly powerful chemotherapy drugs are fighting the disease, they're also, kind of by accident, attacking a vital, unseen ally. And this really gets to the heart of the matter, doesn't it? It's this paradox that doctors grapple with every single day. How can the very treatment designed to save a life, at the same time, open the door to some really dangerous, even deadly, new risks? Well, to understand this, we need to think small. Microscopic. So let me introduce you to your gut microbiome. Just picture a bustling, vibrant rainforest living inside your intestines, teeming with literally trillions of bacteria. And no, that's not a bad thing. It's actually a critical part of who you are. This amazing community works like a hidden organ, helping you with everything from digesting your food to training your immune system. It even acts as a first line of defense against outside invaders. But here's where the conflict starts. Chemotherapy is engineered to kill fast-growing cells, right? That's how it gets the cancer. The thing is, it's not super precise. It also wages war on this incredible inner ecosystem, causing what the source calls collateral damage to the gut lining and all those friendly bacteria that call it home. And that is the unseen battlefield. So how in the world do we know what's actually going on in there? Well, a team of scientists at the Children's Cancer Hospital in Egypt set up this brilliant three-point investigation. They followed 29 kids who were about to start their first round of chemo for a type of blood cancer called acute myeloid leukemia, or AML. And their method was just so elegant in its simplicity. They basically took a snapshot of each child's gut microbiome at three really critical moments. First, at what they called time point 1, right before any chemo started, just to get a baseline. Then time point 2 was 7 days in, to see the immediate shock to the system. And finally, time point 3, about a month later, to check in and see what things looked like during the recovery phase. And what they found. Wow. It was a microbiome that was truly under siege. The evidence they gathered showed just a dramatic and incredibly rapid collapse of this entire internal world. So the first huge finding that jumped out from the research was this. The sheer variety of bacterial life inside the gut just plummeted. Just like a rainforest is healthiest when it has thousands of different species, our gut is the same. And the chemotherapy was just wiping out that diversity. And you can really see that damage so clearly here. This chart, which is based on the study's data, it shows that diversity was high before treatment started, at T1. But look at that. Just 7 days later, at T2, it has totally crashed. And it stayed low even a month into the process. This is a massive red flag, a key sign of an unhealthy, really vulnerable gut. Now, this loss of balance has a scientific name, dysbiosis. Before chemo, you've got this well-regulated, diverse community. But afterward, with so many of the key players wiped out, the whole system is in crisis. And this creates a power vacuum, right? It's a golden opportunity for a few potentially harmful bacteria to just take over all that new, empty real estate. Let's actually look at the specific numbers, because this is fascinating. Before any treatment, the gut was dominated by this group of generally helpful bacteria called firmicutes, making up about 62% of the whole community. And this is crucial, another group called proteobacteria, which includes a lot of well-known pathogens, was just a tiny minority, only 7%. That is a picture of a healthy, balanced system. And now, look at this. This perfectly illustrates the chaos. Just 7 days into chemo, look what happened to the proteobacteria. They exploded from just 7% to 22% of the entire community. The study calls this proteobacterial expansion, and it's a textbook sign of dysbiosis that's linked to chemo. The whole balance has been dangerously thrown off. And within that exploding group of proteobacteria, the researchers were able to pinpoint a specific opportunist, the genus Klebsiella, a type of bacteria known for causing really serious infections. It was basically nowhere to be found before treatment. But the study points out it only appeared after chemotherapy started, just thriving in that disrupted environment. So what's the real-world consequence of this collapse? Well, it's this number. A staggering 38% of the children in the study developed something called enterocolitis, a truly life-threatening inflammation of the intestines. And the study found a direct line connecting this condition right back to that low microbial diversity we just talked about. But the investigation didn't just stop there. The researchers actually stumbled upon a surprising puzzle when they tried to connect the chaos in the gut to another deadly threat, bloodstream infections.
The logical assumption would be that with the gut wall weakened and all these bad bacteria growing, those same bacteria would just leak into the bloodstream and cause sepsis, right? So the researchers asked the obvious question. Could they predict who would get a bloodstream infection just by looking at what was growing in their gut?
And the answer was a huge surprise. Turns out the connection was incredibly weak. For the patients who did get bloodstream infections, the bacteria causing it only matched the dominant bacteria in their gut in 4 out of 10 cases. So this suggests the journey from the gut to the blood is way more complicated than we thought, and maybe the source of the infection is sometimes somewhere else entirely. So, what does all of this mean for the bigger picture? Well, these findings aren't just fascinating science. They really could be a total game changer for how we approach cancer care, with a new focus on protecting these inner allies. Okay, so let's just quickly recap the key takeaways from this whole investigation. Number 1, chemo causes a fast and massive collapse in gut diversity. 2, this collapse is a huge risk factor for dangerous complications. 3, just monitoring the microbiome can give us a critical early warning. And finally, number 4, the link to bloodstream infections isn't as simple as we might have thought. The ultimate goal for this kind of research is to completely flip the script, to go from being reactive to being proactive. I mean, imagine creating microbiome fingerprints for every patient when they start treatment. This could actually let doctors see which kids are at the highest risk for trouble before anything bad even happens. And this all leads to a potential future strategy for making chemotherapy so much safer. You start by profiling the patient's unique microbiome. Then, you monitor it for any dangerous shifts during treatment. And if you see trouble brewing, you step in, maybe with specially targeted probiotics or just a smarter use of antibiotics to help protect the gut without causing even more damage. Which really leaves us with this final, pretty mind-blowing thought. We've always focused on treating the patient and their cancer. But what if the next great leap forward in cancer care isn't just about a new drug, but about learning how to treat and protect this vast, hidden world that lives inside every single one of us?